Okay, love bugs. So 3 and 4 are very similar. I'm going to do 3 just because it's a little bit more unique. But I already sent you my handwritten notes for 3 and 4, so you can follow along. All right, so 4 says John V wants to fence 3 sides of a rectangular exercise yard for his dog, and the 4th side will be the side of the house. So if we have the house here, that is one side, and then we have the fence like this. So we've got an L, an L, and a W. So normally where you would have the perimeter, which he has 80 feet of fencing available, so that's the max feet he can use for the perimeter. So 80 is equal to 2L plus W. All right, and we just want to put this in terms of one thing, so I just went ahead and moved the 2L, so we get 80 minus 2L is equal to W. All right, so now we've solved for it in terms of W, and we can go ahead and start looking for the maximum enclosed area. So area, length times width, and we go ahead and substitute in this 80 minus 2L equals W for W. So we get this is equal to L times 80 minus 2L. And then we can go ahead and distribute and solve. So we get 80L minus 2L squared. Go ahead and rearrange it so that you get it in the same order that you would have like quadratic formulas. So we have negative 2L squared plus 80L. So notice here you've got these like different terms, right? So this negative 2 is your A term. This positive 80 is your B term, and you don't have a C term. And that's just coming from the standard equation, so ax squared plus bx plus c for your quadratic equation. Now, when we're solving here, L, just your variable, but L is the same thing as x, which is the same thing as h if we were solving for like the maximum or the minimum by determining the vertex point. Since this a term is a negative term, a negative a term, it means that our parabola is going to open downwards and we're going to have a maximum point. And so that's what we're solving for here. So we look for a maximum point at the vertex HK. And we solve for H is equal to negative B over 2A. And this is coming from our A and our B terms above. So we do negative 80 over 2 times negative 2. And we get negative 80 over negative 4, which is equal to 20. So 20 is our H. But remember, H is equal to X, it's equal to L. So L is equal to 20. And we can solve for W by doing 80 minus 2 times 20. That's equal to W. So W is equal to 80 minus 40, so 40. So that's actually all the question asks you for. However, if you also still needed to solve for the maximum area, the way that you do that is you're now solving for K. You just plug that into your expanded formula for the area which we solved. So you would get negative 2 times 20 squared plus 80 times 20. So you'd get negative 2 times 400, so negative 800. And remember, you always do the exponent with whatever is in the parentheses right in front of it. So that's why it's negative 2 times 400. So we get negative 800 plus 1600, which is equal to 800 square feet. So if you had to solve for the maximum area, that would be your answer. So I think that is everything. You should be able to use that same strategy to solve for number 3. The only difference is for number 3, you actually had a side here. So when you're plugging it into this equation, you'll have 2w, in which case you can just divide the whole thing by 2, and you would end up solving for 40 is equal to L plus W. You'll still want to put it in terms of one variable and then solve it from the area formula. But your last equation used a perimeter of 20, so you would divide by 2 and you get 10 is equal to L plus W, and then put it in terms of W or L and then solve. So hope that helps. Let me know if you have any questions.